what was this? -1. We had what here? We had 3. And we had 5. We just write it
Had
again.
0 there. Oh wait, where are we?
No, I'm just writing this thing again. And then the last, yeah, I'm just writing.
I have a minus.
Huh?
Oh, okay, yeah. Okay, I see.
Yeah, I'm writing again because everything got wiped out. When that thing ended, everything just got
Okay,
wiped out.
fine.
So, and then
Okay.
and then here we had 1 -1. We had 3. We had 5. And then we said here we had 0. We had 0. And -3. And then it was 3.
Because minus 2 there.
-2, yeah.
Right?
Yeah, it was -2. And
Yeah,
then
minus 2.
we only had 3. And then we
Yeah,
had
3.
-21. Then we had 0. We had 0. We have -2. Right? And then you stop here. Once you get something like this, you stop. The system is inconsistent. There's no solution. No solution. The system is inconsistent. Yeah. So I will show you one of these questions. They talk about this thing. After doing the other 2 examples, I'll show you. Basically, what you see when you change this thing into coefficient, né? It's like this. It's 2. It writes this thing like this: 6, 3, -4, 12, 4. Oh, there's -5 here. -4. -5, 12, 10, -6, and then 18. Oh, I just wrote the same thing here. It's like something like this. If you write it in matrix format, it's like x, y, z equal to 10, -6, 18. If you do multiplication here, you will end up with 2x minus 2y plus 6z is equal to 10. Like the original system of equations that we had, that's what you're gonna get. Yeah? So basically, or you can just think of it as x. This everything here is x, everything here is y, everything here is z, right? Everything in this column. So and then once you have done reducing everything, in other ways, what it means that you could say, let's say you're taking the system back, you could say x from here. You could say x minus y plus 3z is equal to 5. Yeah? And then 0, you just leave it, minus 2y plus 3z is equal to -21. And then here it means that here, let me just write one of them. We've got 0z, which is equal to 0, is equal to -2. And you can never have something like 0 is equal to -2. That's never possible. Like, how can 0 be -2? You understand? Can you hear me? Hello? Hello? Are you there? Oh man. Is my camera having problems?
It cuts off sometimes. I don't think I heard what you
Yeah, I
Can
can
you hear
hear.
me?
Yeah, I can hear you now. I can hear that it cuts off
Oh
sometimes.
shit, okay.
I wonder what it is.
Yeah.
So
uh,
basically, when you take this thing back and put the variables, you can't have you you can't have 0 is equal to -2. It's just not possible. It means there's no solution. Do you have questions about this thing?
No, I understood.
Oh, you sound much better now.
Yeah, I think it's because I was using my thingies. I wasn't using my phone's audio.
Okay. And then the second one is, what is it? It's many solutions. Many solutions. Yeah, infinitely many solutions, or you can just say many solutions. So let's say we have x minus y plus 2z is equal to 5, right? And then 2x minus 2y plus 4z is equal to 10. 3x minus 3y plus 6z is equal to 15, right? This is a system of equations. I shouldn't even be drawing this line. Then we can turn this into an aggregated matrix. So this is like 1 minus 1, 2, 5, 2 minus 2, 4, 10, 3 minus 3, 6, and then 15. Notice something here. Let me show you one trick. Can you hear me?
Yeah, I can hear you.
You see, let me just come back here. You see this equation.
Mm-hmm.
What is the relationship between these two equations? This and this.
Don't they both have X?
This one is they are multiple of each other, which means they are parallel. It's like parallel lines, but okay, it's 3 variables, so it's like parallel planes, because they've got 3 variables. So if it was 2, it was gonna be lines, but it's the same idea. So here we've got 2 parallel. If you multiply this by 2, you get everything here by 2. You get the second one. You notice that? Look, 1 times 2, negative 1 times 2, you get negative 2. 2 times 2, you get 4. 2 times 5, you get 10. Can you notice that relationship?
Yeah.
Even the same thing with the third one. Just now you're multiplying by 3. And you're going to get this one. So straight away, you already have a leading one here, because that's what you try and do. You just try and find the leading one and then try to make everything below zeros. So in this case, we can just make everything zeros because they will cancel each other either way, because they are parallel. They will cancel each other. When it's like this, so we only have, when it's like this, X, Y, Z. When it's like this, the leading one, you solve everything in terms of the leading one. Yes, so now we bring back the x's. It's gonna be x minus y plus 2z is equal to 5. So x is equal to 5 plus y plus 2z. So basically x is in terms of the other variables. Now, look, the difference, are you there?
Yes.
The difference between this one and the previous one, here we had a 0 and then we had a number, which is not true. But here we've got a 0 and a 0, which is true. So this system is consistent. It's true. in nature. It's just a period that the format is like this. When the format is like this, it means we don't have one solution. We have many solutions. So we have infinitely many solutions because we change the other two variables. We call them free variables. This is a leading variable. These are free variables. We can say y and just give it a parameter is equal to s, and then maybe z is equal to let's say s, right? Then just rewrite x here to be 5 plus t plus 2s. This whole thing, we call it a general solution. Because we can get so many solutions from here. For example, let's say t and s is 0. That means we can get a solution of 5, 0, 0. Ne? Or let's say t is 1 and s is 1. That means we can get that's 5, 6, 7, 8. We can get 8, 1, 1. You see? So that's why it's called infinitely many solutions, because your solutions, they depend on the parameters. You can choose any number of t or s, any number that you want, you get a solution, and all of those solutions are correct. So if you get something like this, it means it means there's so many solutions here. So just look at the format. It's very important. Look at the format. There's a 0 and a 0 here. Right. Even if the important one is here is the last row here. This one. The last row. The fact that there's a 0 is equal to 0. Even if we had a number here, maybe 1 and a 3 and some other number, we will still have infinitely many solutions, because we will be having more variables. Basically, we'll be having can I go back? Yeah, you see here we have a leading one here, and then we could turn this into a leading one as well by dividing everything by 2. So it's just like a leading position, right? And then we don't have any other number here. That means these z here, that means we can solve for x, and then we can solve for y as well in terms of z. That's what it means. When you have leading numbers, you can solve it in terms of this. So that z is called a free variable, but here we only have, let me go forward. Here we only have 1, so we can only solve for x. We can only solve for x using the other variables, the two variables, which we call them free variables. And then the last one.
Makes sense.
And then the last one is the simple one. Let's just look in this. Let me look at the book right quick. Let's just check this again. Let me share this for you. Because that one, it's I don't really need to show you, because I'll just show you an answer. I won't go through the whole steps. Where is this book? Yeah, there it is. Let me just show you a difference between a row echelon form and reduced. You see can you see the screen? You see these ones, then?
Yes.
Let me check if I can comment here. Let me draw. Oh yeah, I can. You see this leading one, this leading ones. Can you see them? These are the leading ones. Imagine this being an augmented matrix. Oh, what the hell is going on here? Anyways, you see below the leading ones, there are zeros. Below there's a zero and above there's a zero. Below there's no below, above there's a zero. This one is called a reduced. All of these ones are reduced. All of this. And
Okay.
then this one is not reduced, it's just called a row. It's just called a row echelon. As you can see, below the one there are zeros, below the one there's zeros, but above there's a number. Yeah, even for this one. Even for this one. It has zeros here, but the first number will be the leading one here after the zero, and then this will be the second leading one, and it's on the right hand side. And then below, I think this is a thing. Yeah, so those are the two leading ones. Unless this whole thing is a matrix, then this could qualify as a leading one as well. I actually think, I don't think it's an augmented matrix. Let me do it. How do I even do like this? Oh, why did I just do it? Oh boy. Oh no. I messed up. Yeah, let me just leave it like that. I just want to show you, yeah, you see, one that has a unique solution, it's gonna look something like this. You're gonna have it's just that this one is in reduced form, but it doesn't necessarily have to be in reduced form. You're gonna have these ones like this. This is an augmented one, so. And then when you plug in the x, y, z, then I think there's another variable here. You could call it, I don't know. Oh, what should you call it? Maybe z2. Yeah. So we're gonna have z2 is equal to 5, z1 is equal to 0, y1 is equal to -1. So there's like one solution. We call it a unique solution. So yeah, that's all. That's all. Let me just show you one of those tricky questions. Because I think now you have an idea of this whole thing. Let me show you one of these tricky questions. Yeah, this one. Can you see it?
Yeah, I can see it. Is it the 25, 26?
Yeah,
Right?
25, 26.
Oh, okay.
They put let me just write it down here because it's I need to change the screen again. Oh, where are we? Thing is paused. Okay. It's the last one. It's, can you just you don't want to say it? I'm the one who can say it.
Excuse me?
I'm saying I don't think you can see the question, so I need to move up and down the screens looking for it.
Okay.
It's 1, 2, minus 3. 1, 2, minus 3. 1, 2, minus 3. 3 minus 1, 5. 3 minus 1, 5. 3 minus 1, 5. And then we've got 4, 1, 4, 1, 4, 1. Then we've got am I even recording this thing? Oh yeah, there it is. And then we've got a squared minus 14 plus a squared minus 14. A squared minus 14. And then a plus 2. We'll just verify. 4, 1, a squared, then 4, 2. 3 minus 1. 3 minus 1, 5, 1, 4, 2. Yeah, it sounds like correct. Then we've got 4, 2. So basically we need to find, you see, we have this matrix. We need to find the values of A for which this system has no solution, one solution, and I think infinitely many solutions. Let me just check. Exactly one. Oh yeah, yes. Infinitely many solutions. Many solutions. So you do the same thing. You do the same thing. This one is even easier because you already have a 1 here. You just pretend as if you are trying to solve the equation. You do the elementary row operations and try and reduce this thing. I mean, and do row and try and put it in row echelon form. So here we're gonna have 1, we're gonna have 2, we've got minus 3, we've got 4, right? And then I'm just gonna do everything in one step. You see, I have 3 here. I'm gonna say minus 3 times the first row, and then I add them together. I'm gonna get 0. Then I'm gonna say again, minus 3 times 2, which is minus 6. And then I add 2 minus 1, it's gonna be minus 7. I do the same thing. Minus 3 times minus 3 is 9, plus 5 is 14. Minus 3 times 4 is minus 12, plus 2, which is minus 10, right? The same thing here, always gonna be 0 there. Minus 4 times minus 4 times 2 is minus 8, plus 1, which is minus 7. Minus 4 times minus 3, that's 12, plus this. It's gonna be what? A squared minus 2. Am I right? 12.
Yeah. Wait.
Yeah, I think I'm right.
Yeah, you're right.
And then minus 4 times 4, it's minus 16, plus this, it's gonna be a minus 14. Yep. Right. And then, as if I'm solving it, I just continue. I already have a leading 1 here, and then I come back to the next one. I'm trying to get 1 here. But I wouldn't advise you to get 1 here. You know why? Because if you divide by 7, you're gonna get a fraction, and the fraction will it's gonna mess your life up. So you know that the next one in line is this one, right?
Yeah, it's gonna be a bit confusing.
So I'm just gonna leave it. I'm just gonna leave it like that. In this case, it doesn't require us to do anything to it. Sometimes we have to play around with it so that we get what we want. In this case, I'm just gonna leave it minus 10, because I know I'm trying to get a 0 here, right? How can I get a 0 using just 2 lines? this one is not in the place, so we're done with it. We've used it to get zeros here. Now we are here, and we're trying to get 0 here. So we can add both of them. Basically multiply, maybe we can just multiply it by negative, you know? Multiply it by negative. And we'll just put it there. Right? And then we say, we add them together. What do you get? 0 here.
Yeah.
And then I add this with this, I get a squared minus 16. Then I add this 2, I get a minus 4, right? So I've got this
Yes.
leading one, and then this. And there we go, the most important line, this one. Remember I told you about the last column and these two numbers.
Yes.
These two numbers. And I said, for this thing to have no solution, you're gonna have a situation where you have this a squared minus 16 is equal to 0. Yeah. While a minus 4 is not equal to 0. Then you're not going to have a solution, right?
Mm-hmm.
So it means if we can say a minus 4 here, a plus 4 is equal to 0, it means a is equal to 4. Or, so we need to solve this first before we can come here. And then a is equal to minus 4. And then we've got two a's now. We need to figure out which one will make this thing not equal to 0. But this needs to be true. So if we take a is equal to 4, and then we say 4 minus 4, what are we going to get? We're going to get 0, and we're not looking for 0. But if we say a minus 4, what do you get? We get minus 8, which means this is the solution we're looking for. That means a is equal to minus 4 will give no solution. Ne?
Yes.
And then I want to do everything on the same screen. I'm just gonna cancel this one here, because the most important one is this, is the last, is this matrix that we managed to derive this one. And then now we want one solution. Well, what did you notice with one solution? Well, with one solution, the only requirement is for this thing not to be 0. If this thing is not 0, then we are good to go. Remember, we need this thing to be leading 1. In order for it to be leading 1, there has to be a number. If there's no number, then it's the other option. It's one of the other options. So we want this thing minus 16 not to be equal to 0, right? This one doesn't matter. This one could be 0. This one could be 0. It could be any other number. It will still be a solution because z is equal to 0 is a solution. So the most important one here is this one. So in this case, we can just say a should not be equal to plus minus 4, because it's going to make this thing 0. And if this thing is 0, then we don't have 1.
Okay.
Yeah. So those are the conditions for one solution. And then infinitely many solutions. Infinitely many solutions. This was 1. This is 2. Infinitely many solutions. I said we need both of these to be 0. Right? So we want a squared minus 16 to be 0, and a minus 4. Oh, left with 10 minutes. That's good. We'll be done. We will be done before that, I think. Is equal to 0, right? So here we've already done it. Is equal to 4, or a is equal to minus 4. And then we check, because we've got 2 here. We check if it goes hand in hand with this one. If we take a is equal to 4, we're gonna get 0, which is what we want, right? So I'm just gonna take this one. If we take a is equal to -4, we're not gonna get 0, and that's not right. So this one is not valid in this case. This one was not valid in this case, but it is valid in this case. So this is the answer. A is equal to 4. It's the condition. So yeah, so basically the whole idea about this case they normally put here is understanding these 3 things: no solution, one solution, and infinitely many solutions. So pity my screen has been wiped out, and these things you would only know them if you know how the equations behave when there's no solution, when there's one solution, and when there's infinitely many solutions. When there's infinitely many solutions, these 2, the last 2, they are equal to 0, or the whole line basically is equal to 0. When there's one solution, this number must never be 0 by any means. When there's no solution, it's just something that doesn't make sense. You have a 0 here and then you have a number, which doesn't make sense. How can 0 be equal to a number? So that's the most difficult part about these matrices. The next of the next chapter, the next lesson is just about going through practicing the stuff. It's not something you really need to think extensively about.
Okay.
Yeah, it's just about knowing how to, because the next section is it's about let me check, because we've done 2 chapters already. The next session is about the next session is about matrix operations, like adding matrices, subtracting matrices, multiplications. That's something you just need to practice. And then
Yeah, I think those ones I probably am fine with, just the inverse part, because that one is not that difficult to adding and multiplying them and subtracting them.
oh, okay. Yeah, the rest of the things, man, it's easy, man. It probably won't even take more than, probably gonna take 20 minutes lessons next time. Because it's
Oh,
basic.
okay.
Yeah, yeah.
Can I also get some exercises on this
Yeah,
to like practice on?
I'm definitely
Yeah,
gonna
just so
I'm definitely
just
gonna
so I
give you.
see that I've grasped it, and then if there's something I struggle with, I'll just text you.
Okay, no problem.
Okay, thank you so much.
All right, bye-bye.
Bye.